It's commonly understood that calculations in artificial neural networks are performed not simply with numbers, but with tensors. Input data, neural network weights, bias, output data are all tensors. From a practical standpoint, a tensor is a multidimensional array of numbers with additional metadata, specifying things like the data type of array elements and the array's dimensionality, shape. Being multidimensional, an array can be a scalar number, vector, matrix, three-dimensional matrix, and so on. Each array dimension along any axis can be either static or dynamic, which is also specified in the Tensor's metadata. If a model is designed to process text strings of arbitrary length, creating an input tensor might look like this. First comes the essential step of determining what type of tensor the model accepts as input. Then we take the required text string and tokenize it. This gives us a one-dimensional array of numbers whose length depends on the string length. Next, we create an input tensor from this array, specifying the necessary metadata. For example, indicating that the tensor contains a one-dimensional array of dynamic length with int32 data type. If a model processes 512 by 512 pixel grayscale images, the input tensor for this model would likely be created with a fixed size 512 by 512 matrix, where each element represents a pixel scalar value. The metadata would specify that the tensor contains a static 512 by 512 matrix with, say, uint8 data type.